Hey everyone, we're going to look at number 2 in section 4.3, and this is dealing with the MVT. What's that? That's the mean value theorem. That's what we started with in the lecture for this section. And we're going to find all points C satisfying the conclusion of this theorem, the mean value theorem, for the given function. The function's y as a function of x is x cubed, and this given interval between from -3 to 4. So just a refresher on the mean value theorem. It basically says if we have a function f that's continuous on a closed interval, including the endpoints, right, and differentiable on the open interval, so all values between. Remember, differentiable, well, continuous means, right, there's no holes in the graph, no breaks, no jump discontinuities, no discontinuities of any kind. It's continuous from the right at B, continuous from the left at A. No vertical asymptotes, etc., etc. Differentiable means, right, the derivative exists everywhere between A and B, which means basically the graph is smooth, there's no sharp turning points, and we don't have any vertical tangent lines. Okay, so with those two conditions, then there always exists at least one value C, some number in that interval. Right, and in our interval here from -3 to 4, so some value C would be something between those two numbers, such that the derivative evaluated at C is equal to this big expression. This again is basically the average rate of change of the function over that interval. It's also the slope of what we call the secant line on that interval. And I talk about this in the lecture video, so I would refer you to that to make sure you understand what's going on here. But it basically says the derivative of the function at C is equal to this value. And the derivative, remember, is the instantaneous rate of change of the function, or the rate of change of the function. And all this is really saying is that for any function with these conditions, its instantaneous rate of change will be equal to the average rate of change for the function over that interval at least one point, right? C, and maybe multiple points, maybe more than 1 point, but there's at least one guaranteed. So our goal is to find the C here. Okay, so this is just an existence theorem. It doesn't tell us really how to find C other than the fact that we have to solve this equation, and that's what we're going to do. We have to set this equation up and solve for C. So this part's just a calculation. We know what the function, it says f here, but of course here our function is y. And so the values of A and B, right? A is -3, B is 4. So what is the value of the function at A? So the f of A here, I'm going to, y of A, I did f, but it should be a y because our function is y in this case. Y of A is just y, just got f on the mind here, y of -3, right? And y of -3 is just -3 cubed, which is -27. And then y of B is, of course, y of -4. No, sorry, y of +4, because the value of B is 4. And then y being x cubed gives us 4 cubed, or 64. Okay, so just plugging into this is going to be y of B minus y of A over B minus A now. So y of B is 64 minus y of A is -27. B is 4. A is -3. So be careful about subtracting. 64 minus -27 is 64 plus 27, which is 91. 4 plus 3 really here is 7. 91/7 is actually exactly 13. So this average rate of change for this function on this interval is 13. So we got this side, 13. I need to know what the derivative is, right? So how do I find the derivative of x cubed? That's a piece of cake, right? Bring the 3 down, subtract 1 from the exponent. By the power rule, I get 3x squared. So what I want to have is y prime of C equal to this value, which we calculate to be 13. So what is y prime of C? If I replace x with C, I get that. Solve for C now. So it's basically solve for C in this equation. How do I do that? I divide by 3. And then take the square root, including both the positive and negative roots. Don't forget, right, to do that when you have an equation to solve, you have to include both the positive and negative roots. Okay, and remember this function we're dealing with, its domain is all real numbers. Okay, so here are the two numbers, and they want them separated in list form. By the way, they want the values of C guaranteed by this mean value theorem, so we only want the values of C that are in this interval between -3 and +4. And both of these numbers are in that interval. If you take your calculator and do 13 thirds, and take the square root of that, you'll see both of these numbers are in this interval between -3 and 4. Okay, so that's important too. If you get anything for C here that's not in this interval, then that's not the values of C we're talking about, right? Because the values of C we're looking for are in this interval. You could have other values of C outside the interval. The derivative could be equal to this average rate of change on values that are, say, more than 4 or less than -3. Okay, so in this case, though, we want to include them. Okay, hope this is helpful as always. If not, let me know.